Hello and welcome to helpyourmath.com. In this video, we're going to talk about the operations and fractions. What is a fraction? You probably said, it's a part of a whole. Am I psychic or what? But really, a fraction is a number. More specifically, it's a real number. And even more specifically, it's a rational number. That's it. That's all a fraction is. It's a number. Usually, fractions represent the values between integers, but we can also write integers as fractions too. Just to review what a fraction looks like, usually we write it as a over b, where a, that thing up there, is called the numerator. The thing in the middle is called the fraction bar. And the thing on the bottom is called the denominator. And there we have it. Really what the fraction bar is it's actually a division symbol. So we could actually rewrite any fraction, and if you ever want to convert it to its equivalent decimal, you do the numerator divided by the denominator. And we can talk more about that when we get into a little more of the fractional details, but that would be another option. Now, fractions are superior to decimals because decimals could keep going on and on and on. Like if you typed 1/3 into your calculator, or if you typed 1 divided by 3 in your calculator, which is the fraction 1/3, your calculator would say 0.333 or 0.33333 or 0.33333. But that's the thing, it's 0.3 where the 3 repeats and repeats and repeats and it never ends. So what you're seeing in the calculator is an approximation of the number 1 divided by 3. The next thing we need to address is the two different ways that we can categorize a fraction. We can have a proper fraction or an improper fraction. A proper fraction is a fraction in which the numerator, that top value, is smaller than the denominator, the bottom value, such as 1/5, 9 over 127, 6 over 21. And then, fun fact, all proper fractions lie between -1 and 1 on a number line. So anytime the numerator is smaller than the denominator, that number has to be somewhere between -1 and 1 on a number line. All other fractions are improper fractions. An improper fraction is where the numerator is greater than or equal to the denominator, such as 15 over 7, 5 over 5, or 18 over 1. So all of those we call improper fractions. Now, if we're just talking about fractions and these other types of numbers called integers, integers are the numbers that don't have fractions or decimals. So that includes numbers like 1, 2, 3, and you can keep counting that way. It includes 0, and then it includes all the negative numbers. So we can take any of these integers and rewrite them in fractional form, which we see here, 18 over 1. So 18 over 1 is equivalent to 18. But if we need a fraction, we can always put it over 1. So that's a property of fractions that we can apply. What exactly can we do with fractions, you may be wondering? Great question. First of all, we can simplify them. Second of all, we can love them. Third, we can add or subtract them. Fourth, we can cherish them. Fifth, we can multiply them. Sixth, we can divide them. There are other things that we can do with fractions, but these are the 6 things we're going to focus on in this video. Let's start with simplifying fractions. When we simplify a fraction, that means the numerator and denominator have no common prime or composite factors in common. So that means that the only factor they have in common is 1, because 1 is neither prime nor composite. To simplify, we divide, sometimes we say cancel, out the common factors. Key words you may see that indicate a fraction wants to be simplified: reduce to lowest terms, simplify, write in simplest form. Pretty much always if you're dealing with a fraction, or there's fractions in a problem, or your final answer is a fraction, it should be simplified. Simplifying just means that there are no common prime or composite factors. Now, I also said here that we divide out common factors. And there's 2 ways that we can look at how we do this. But what we're really doing is we're applying the multiplication identity, which is you can take any number and multiply it by 1, and you don't change the value of that number. Now, of course, 1 doesn't look like 1. 1 comes in all sorts of flavors. 1 is the same thing as 5 divided by 5, because 5 divided by 5 is 1. 1 also equals 18 over 18, because 18 divided by 18 is 1. 1 could also equal negative 14 divided by negative 14. So we have all of these different ways of writing a 1, and we can also then divide these things into some other number if 5 is a common factor to the numerator and denominator. So let's take a look at simplifying some fractions. Our first example, we have 15 over 20, and I was just talking about 5. 5's ears must have been burning because 5 is the common factor. It goes into 15 3 times, and it goes into 20 4 times. One way we could show that we're going to not do anything mathematically incorrect, that we're doing good math, is we show we're going to divide the numerator by 5, and we're going to divide the denominator by 5, and that's going to give us 3 over 4. Something else we could do is we could rewrite 15 and 20 as 5 times the other factor. So 15 is 5 times 3, 20 is 5 times 4, and then we can cancel that way, and then we see that 3/4. When we get really comfortable with simplifying fractions, we don't even show the step. We might just cross them out and put the other factor, the remaining factor, somewhere close by. In the second one, we have 24 over negative 18. Now, in the integers video, we're going to see that when we divide a positive by a negative, the final result will be negative. Usually, when we're doing a final answer, we're going to put the negative in line with the fraction bar, but it really doesn't matter. You can have it in the denominator, you can put it in the numerator, you can put it exactly in the middle. You can't do all three. I mean, I guess technically you can, but it wouldn't be simplified, and that'd be weird. But really, just choose one place to put it. And now we're going to focus on the 24 over 18. So what do those have in common? 24 and 18 have a couple numbers in common. So in that case, we want to try to figure out what the biggest is. But even if we don't, we can still get to the right answer. So I'm going to start with the biggest. The biggest factor that they have in common is 6. I'm going to divide 24 by 6, and I'm going to divide 18 by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. And we're going to leave it like that. Notice that the negative isn't like lumped in. I also kind of did it sideways, but that was not intentional. It's not, like nobody's going to look at that and wonder if I remembered the negative or not. So we want to make sure that we're giving it some breathing space so that way we know that it exists. Now, let's say you looked at 24 and 18 and said, hey, they're both even. Therefore, they're both divisible by 2. Great observation. When we divide these both by 2, what's going to happen is I'm going to put that negative in the middle again. 24 divided by 2 is 12. 18 divided by 2 is 9. But 12 and 9 still have a factor in common, so we would just need to simplify again. 12 and 9 are now both divisible by 3. Well, they're always divisible by 3. And we would get negative 4 over 3. And that would be our final answer, just as we saw there. So even if you don't choose the right factor, I mean, it's not the wrong thing to do. It's just now you have to do it in 2 steps. That's totally fine. It works. It gets us there. It does maybe perhaps require a tiny bit more work. And our third example, we have negative 60 divided by negative 40. First of all, a negative divided by a negative will produce a positive quotient. So we're not going to have any negatives. And then what's a common factor between 60 and 40? Well, the one that jumps out at me is 10, but there is a bigger factor. So again, you can do it in 2 steps with 10, and then it would be 10 and 2, or you can do it all at once with 20. So I'm going to divide them both, and maybe even to really emphasize the negative, I'll divide them by negative 20 and really, I have to be consistent here, divide them both by negative 20, and that really gets rid of that negative in both the numerator and denominator. You don't have to, that you can just divide them both by 20 and just say a negative divided by a negative is a positive. This is going to give me 3 over 2. And that's how we simplify these 3 fractions. Now you might be wondering, because the second one and the third one are both improper fractions. And improper fractions, sometimes people have it in their head that they have to convert it to a mixed number. You absolutely do not have to do that. This is absolutely correct. So I'm going to put boxes around these because these are correct. We just want to make sure we have the correct sign and we don't have common factors between the numerator and denominator. And that's simplifying fractions. What's up next? Adding and subtracting fractions. When we want to add or subtract, we must find a common denominator, preferably the least common denominator, but any common denominator will do. So we're looking at the denominators, those bottom numbers, and we're saying, what do these numbers both go into? Very common denominators are 12, 18, and 24 because they have a lot of factors. So those are some to look out for. If multiplication is not your strong suit, I do suggest practicing it and kind of, getting a little bit more skilled at it because it is really helpful. I know we all have calculators that we carry around with us all the time, but it's good to not have to do 2 times 3 on your calculator and just know that 2 times 3 is 6. Okay, once all the terms have the same denominator, so only when they have the same denominator, that's when we combine the numerators and we keep the common denominator. So the denominators are like the units in this case, and we need them to have the same units. Like if I said add 3 inches plus 12 feet, you can't add 3 and 12 and it make any sense. The 15 has no meaning because they were 2 different units. It's kind of the same with fractions. If we have 3/7 and I already forgot my units now, and 7/15, we can't add anything there because they don't have the same unit. It doesn't work that way. Okay, once we've added, then we're gonna, or subtracted, sorry, then we're going to simplify if possible. Okay, so we're being told to combine, then simplify if possible. So we see that simplify again. That means no common prime or composite factors. In our first example, the denominators are 4 and 3. The least common denominator, so I'm going to say least common denominator between 4 and 3, as promised, the least common denominator is 12. If you get stuck, like if you're looking at the 6 and 8 and you're like, I don't know, you can always multiply them. It will create a common denominator. It does not guarantee to be the least common denominator, but you know what? It works, and that's just fine. Okay, so now we need to write the equivalent fractions. I have a 4 in this first fraction in the denominator. I need it to become a 12, so I need to multiply by 3. But whatever I do to the denominator, I also have to do to the numerator. So the first fraction, 1/4, is equivalent to 3/12. My second fraction is 2/3. The denominator is a 3, so we need a factor of 4. Whatever I do to the denominator, I need to do to the numerator. And 2 times 4 is 8, and 3 times 4 is 12. And now that they have the same denominator, I'm ready to add. We add across the top, so we keep that common denominator. I can even put the 12 down here. We have 3 plus 8 in the numerator. 3 plus 8 is 11. We get 11/12. Can we simplify 11/12? No, we cannot. It's pretty much guaranteed that if 2 numbers are consecutive, meaning one right after the other, like 11 and 12, it's impossible to simplify them. So 11/12, final answer. What do we have next? Okay, I want to combine these. I have one negative and one positive, so we'll deal with that when we get there. But we need to start with the denominators 8 and 6. Let's see. So 8 and 6 are not the same. We need to identify something that they both go into. Remember, the strategy I talked about was you could just multiply them, but we can get a smaller common common multiple than 48. They also both go into 24. So we're going to rewrite both fractions to have this denominator of 24. And because I do have that negative 7/8, when I'm going to add these fractions, I'm going to put the negative in the numerator because I want to make sure the sign doesn't get lost. And if I put it in the denominator, then they won't be the same number because one's positive and one's negative. So anytime there's a negative, you need to bring it up to the numerator. And when I multiply, let's say I have 8, I want to get to 24, so I need to multiply by 3/3. So that negative I'm going to bring to the numerator. I'm going to rewrite this as negative 21/24. And we're going to add to that, let's see, the 6, I need a factor of 4. And we're going to multiply 5 by 4. I get 20/24. I'm ready to add. So I'm going to combine the numerators and keep it over that common denominator. When I have opposite signs, I have a negative 21 and a positive 20. I don't add, I subtract. And that would give me a -1 because I have one more negative than I do positive. So my final sum here ends up being -1 over that common denominator, 24. Notice I put the negative kind of back in the middle. You could keep it in the numerator too, that's fine. And finally, for our last example, I actually want to add just one more fraction here. I'm going to put 3/8 just to see what happens when we do have 3 different fractions. So again, I need to find the least common denominator, but now I have 3 different numbers to look for. I have 9, 12, and 8. And if this one might be tough because I think my go-tos, my 12s, my 18s, and my 24s don't work because 9 doesn't go into 24 and neither 9 nor 8 go into 12 and most of these don't go into 18. So we might need another strategy. There's a couple different strategies that we can use, and I definitely don't want to multiply the 3 denominators because that's going to give me a very, very big number, and then I'm going to have to try to simplify it, and that's going to lead to a host of mistakes. So one strategy is we're just going to start writing multiples of 12, and as we go, we're going to say, does 9 go into this? And if the answer is no, we'll move on. If the answer is yes, then we're going to see if 8 also goes into it, because we need all 3 numbers to go into this multiple. So we start, and I'm choosing 12 because it's the biggest. So the first multiple of 12 is 12, or the first positive is 12. Then 24. I already said that 9 doesn't go into 24, so that's done. Next we have 36. 9 does go into 36, so now we check 8. 8 does not go into 36. We move on. Next we look at 48. 9 does not go into 48, so we skip it. Next we have 60. 9 does not go into 60, so we skip it. Next we have 72. 9 goes into 72, so now we check 8. 8 also goes into 72. Ding, 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 ding. We found a winner. So 9, 12, and 8 all go into 72. That's our least common denominator. That's the one we want to use. And to rewrite -2/9 with a denominator of 72, well, 72 is actually 8 times 9. So my strategy almost worked. We just had that pesky 12 to deal with. I'm going to multiply by 8 over 8 because 8 over 8 is secretly just multiplying it by 1. I'm going to move the negative up to the numerator, so that's going to give me -16 over 72. Subtracted by 12 to get to 72 is times 6, so I'm going to multiply by 6. And that's going to give me 30 over 72. And we're going to add on this bonus one, the 3/8. And 8 needs a factor of 9 to get to 72. And 3 times 9 is 27 over 72. Now that they all have the same denominator, the signs in between I'm going to put up with the numerators, right? Because we need the 72 that's consistent among all 3 fractions. We have -16 minus 30 plus 27. You can do this from left to right. I usually like to combine things that are the same sign, which actually is going from left to right. These two make, let's see, they're both negative, so we combine them. That's -46. And then -46 plus 27 is 19, -19. And we get -19 over 72. Can we simplify this? Well, 19 is prime, and it doesn't go into 72, so we cannot further simplify it. Our final answer with the addition of my 3/8, I'm going to put the negative in the middle, 19 over 72. How are you feeling about adding and subtracting? That's great to hear. I assume you gave some positive thumbs up, right? Yeah, of course. Okay, next up, multiplying fractions. Unlike addition and subtraction, for multiplication, we do not need a common denominator, and I don't recommend finding one because that always leads to mistakes. Don't make a mistake, no common denominator for multiplying. There are 2 steps to multiply fractions, and they can be done in either order or both. For the sake of rational expressions, you may want to first check to simplify, then multiply the numerators together, then multiply the denominators together. But many students switch the order, and that's totally fine, no problem. So I'm going to show my way, which is to simplify first, because first of all, if you simplify before you multiply, then you get to deal with smaller numbers. You don't have to multiply bigger numbers, which is great. I don't like having to multiply bigger numbers if I don't have to. In our first example, we have 1/4 times 2/3. So what we're looking for is any common factor between the numerator and denominator. Now 2 is a factor of 2 and it's a factor of 4, so we're going to divide one numerator by 2 and one denominator by 2. And usually what we do is we just cross this out and put the remaining factors. So 2 divided by 2 is 1, 4 divided by 2 is 2. Now we're dealing with the bluish 1, or navy I guess it is, the navy 1 and the navy 2, and the 1 and the 3. Because the numerator is all 1s, we can't simplify any further. In the numerator, 1 times 1 is 1, and in the denominator, 2 times 3 is 6. And our final answer here is 1/6. Next up, we have negative 7/8 times 5 over 6. First, going back to like the signs with positive and negative numbers, a negative times a positive will be a negative in the end. And now I'm looking to see, do 7 and 5 have any common factors with 8 or 6? No, they don't. 7 and 5 are both prime and neither of them go into 8 or 6. So we just multiply straight across. 7 times 5 is 35. And 8 times 6 is 48. Since we couldn't simplify when they were two different factors, we can't simplify now either. And lastly, we have negative 2/9 times negative 12. Now, one thing I didn't mention in my little blurby about multiplying fractions is that we do want the fractions to be proper or improper fractions. So we need to turn negative 12 into an improper fraction, and we can do that by putting it over 1. So what we're looking at is negative 2 over 9 times negative 12 over 1. We have a negative times a negative. That produces a positive, so I can kind of ignore those signs. And then, does 2 or 12 have anything in common with 9? Yes, 12 does. 12 and 9 are both divisible by 3. So we divide 12 by 3 and we get 4. We divide 9 by 3 and we get 3. Right? So we're writing down the leftover, not the thing we divided from both. Now I'm showing the division. Frequently we don't show that step. Now I'm left with a 2 and a 4 in the numerator and a 3 and a 1 in the denominator. 2 times 4 in the numerator is 8. 3 times 1 in the denominator is 3. And we're going to leave our answer in simplified form. And that's multiplying, kind of friendly, right? And the last thing, we can divide fractions. It's division of division. Isn't it so meta? Of course it is. When we divide fractions, there are a few strategies, but I'm only going to talk about this one strategy today. And it's the strategy that we can rewrite the division as multiplication by multiplying by the reciprocal of the divisor. Once we've rewritten as multiplication, then you can go back and multiply just like we did, like we know and love. Reciprocal of a number is when the numerator and the denominator are switched. And the other thing we might need to talk about is the divisor, because that's kind of a new word. I'll get to that in just a second, in the middle of my 30-second rationale for this property. Okay, are you timing me? Here we go. We're going to let A, B, C, and D be non-zero integers. And I'm going to have the fraction A over B divided by C over D. And this one is called the dividend, and this one is called the divisor. So this is the one that gets flipped. Okay, this is going to take me longer than 30 seconds because I'm trying to write the word dividend. Now, unbelievably, I'm actually, for this demonstration, I'm going to rewrite this as a complex fraction. Because did you know that there are complex fractions? Fractions weren't complex enough, so we had to complexicate them. Okay, so here we go. We have a complex fraction, right? Because the fraction bar does mean division. Well, I don't want a complex fraction. What am I doing? So instead, what I'm going to do is I'm going to use the fact that I know any number times its reciprocal multiplies to 1. And I'm going to say, bye-bye, denominator. I'm going to multiply you by your reciprocal. Now, if I multiply the denominator of a fraction by something, I need to multiply the numerator of a fraction by that same thing. The C's in the denominator cancel, the D's in the denominator cancel, and lo and behold, I have that original first fraction being multiplied by the reciprocal of the divisor of that second fraction. There are a bunch of shortcuts or ways to remember this, but I always think it's helpful to see why it works. I think some I've seen are keep, change, flip. I think that's the most common one is keep. You keep the first one, you change division and multiplication, you flip the second one. Now, of course, this does only work when we have proper and improper fractions. So if we have a mixed number or if we have an integer, we do need to rewrite it as a fraction. And the other thing I just want to point out is that when we do have division of fractions, we can't look to simplify until we've rewritten it as multiplication. So there is a specific order that we have to take. First, rewrite it. Well, first, if you need to fix anything, fix those things. Then rewrite as multiplication. Then you can look to simplify. So this first example, we're going to rewrite the division as multiplication by doing 1/4 times 3 over 2, the reciprocal of 2/3. And now when I go to look to simplify, well, my numerator is 1 and 3, and my denominators are 4 and 2. There's nothing to simplify. We multiply straight across. 1 times 3 is 3. 4 times 2 is 8. 1/4 divided by 2/3 is 3/8. Next up, we just have this negative, so we do have a complex fraction here. Well, we'll use it, right? Why not? We have the one single negative, so that just means that our final answer will be negative. I don't want a complex fraction. So what am I going to do? I'm going to multiply by the reciprocal of the denominator. If I do that to the denominator, I do that to the numerator. What that's going to do is that's going to put negative 7/8 being multiplied by 6 over 5. These 5's cancel, these 6's cancel. And now I'm going to just put the negative. I'm going to start with that so I don't forget it. I have 7 and 6 in the numerator. I have 8 and 5 in the denominator. 6 and 8 do have a common factor of 2, so I'm going to divide them both by 2. When I divide 6 by 2, I get 3. When I divide 8 by 2, I get 4. And now I can't simplify any further, so I multiply straight across. 7 times 3 is 21. 4 times 5 is 20. And we have that negative waiting for us out front. We know we can't simplify further because they are consecutive numbers. Last up, we have negative 2/9 divided by negative 12. First, we need to rewrite negative 12 as an improper fraction. So we're going to say negative 2/9, still divided by, because I'm just rewriting it as negative 12 over 1. Now I'm ready to rewrite the division as multiplication by multiplying by the reciprocal. That would be negative 2/9. This one stays the same. We change it to multiplication, and this becomes 1 over negative 12. Now, in this multiplication, I have two negatives. A negative times a negative is positive, so I don't have to worry about a sign because we don't have to write the plus sign. And the numerator, the only non-1 factor we have in the numerator is 2. 2 and 12 have a common factor of 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Now, because the numerator is all 1s, I can't go any further. 1 times 1 is 1. In the denominator, 9 times 6 is 54. Just double checking, negative divided by negative is positive. And this one, negative 2/9 divided by negative 12, I end up with 1 over 54. This has been a review of the operations and fractions. Thank you for stopping by.